All right, hello. Welcome to this video. Today we're going to be looking at a university assignment for a third year class called Legacy Systems and Computing. In this assignment, you have to write a decently simple program in multiple different languages. We have three choices here. The languages are specified. So we can't really choose what languages to write the program in, but we can choose what program we can do. It's like 3 p.m. Sunday. This thing's due, I'm pretty sure like next week or something, but it's quarantine, Corona season, so we're a little bored here in the house, and we might as well just record ourselves doing this and sort of for educational purposes for later on. I guess for people to watch who are new to computer programming, and for myself later on, so I can sort of see, and where I can improve in my problem solving. So far I have a pretty decent mark in this class, and I wouldn't want to mess that up. So I barely looked at this before. I know there's three programs we can choose from. There's this calculating E, which just doesn't look fun. There's the GCD, which I've done a million times. And then there's this Russian peasant multiplication. And if you guys don't know, I am Russian, so this already looks appealing. And it's kind of weird too. This has to do with like odd and even numbers for multiplication. An algorithm for performing by repeated halving, doubling, and additions. It's well suited to multiplication of large numbers, such as numbers whose product has twice many digits as the calculator's normal word size. Given this equation, multiplier, multiplicand equals product. The basic algorithm is this. If the multiplier is odd, add multiplicand to the product, have multiplier, or half the multiplier, and double the multiplicand. I guess making it even. So 7's odd. So you divide by 2 and I guess you int it. This becomes even. 3 is odd. Three is odd, so P close 9 plus 18, so you add this number, the multiplicand, and then you just keep doing this until the multiplier reaches 1. So this does not seem too difficult. There's a recursive algorithm they literally give you. Pseudocode provided for recursive version of the algorithm. Translate the recursive algorithms into Fortran, Ada, and C. Write a non-recursive version of the algorithm and code them in the same three languages. Oh, so we have to write like 7 algorithms. 3 and 3 for these languages. And then 1 in COBOL. So I actually previous assignments were in Ada, Fortran, and COBOL, so I have a bit of exposure, but I haven't done like Fortran in like a month and a half. I have some code from my previous assignments, my Fortran code, my COBOL code, and my Ada code. Previous assignments were difficult. They're not difficult, but the Fortran assignment had to do with like compression. The Ada assignment had to do with like I forgot, and the COBOL one was also something. So this should be interesting. I think I want to start with C, just because I haven't done C in a while also. And we're gonna, I guess, use this as like the number. So I guess we might have to use like longs or something. So Here I made a folder. I'm on like a school server. Let's call this peasant or Russia. Or what do they want me to call it? The code. Yeah, okay, there's nothing too interesting here. Alright, I'll just call it Russia.c. Could make a makefile, but that just like slow us down a bit. Let's close Postman. Let's close mail. For the lag. No, I did mention that I haven't done C in a while. So let's see if I still got my C skills. Warnings, ANSI, pedantic, Russia.c, Russia.out. Oh, A.out. I guess I have to specify it. I like calling the programs the same thing. All right, cool. So we got some C code in the building. Now, is there translate the algorithms into add and C, right? No recursive. The code. I guess we'll just create two. Like, is there a long in C? AB. Let's do like a little prompt, I guess. Enter the what do they call it? Multipland or something? Multiplier. Enter the multiplier scanf for LLD. And read A. And then same thing for multiplicand. And we'll just read B. GCC equals std. Or what the GCC equals was like C99 or something. GCC equals, or was it std or something? Set C set GCC flag, I think that's called. Set GCC flag. Too late to see. C, that's C++. I guess C 2000 GCC equals C 99. Or what was like, how do you set the flag? Oh, why did I do GCC? Oh, I'm so stupid. It's std. No? std equals C 2000. Use long in C. What version of C supports long? Power of C99. So why can't we do this? C99, yeah. C90, why does it think it's C90? How to compile C99. STD equals C99. Or maybe I'm not reading it right or something. Let's see. Stack Overflow always helps. LLU. Maybe is it LLU? Unsigned or something? I don't know. What does that even mean? Wow, how can I read in? How can I read in without a warning? Scanf. Scanf long man. See. Because I know in C++ you can read in an LLD. Well, let's have this for now. Alright, yeah, I'll just have that for now. Product. And this will be a long. It's gonna take these guys. And then let's just try to not look at this recursive algorithm. Let's just try to figure out from here like how to write a recursive algorithm, because I think that's just more fun than just copying it from the thing. So basically, until multiplier reaches 1, what's our base case? Is basically like if m1 equals 1. Oh, sorry, JavaScript syntax. We return product. And I'm pretty sure I have to pass in product as well. Product being, yeah, product being here. Return prod. Yeah, so if m is 1, we just return the product. Then we say, yeah, if the multiplier is odd, if m1 mod 2, odd is 1, we return, I'm pretty sure, product, where it's like m1 divided by 2, which will floor because it's an integer division. Then we do like m2 times 2, I'm pretty sure. Add multiplicand to the product. And then like prod plus m2. F multiplier divided by 2. P steps 2 and 3 until multiplier reaches. So what if it's not odd? Or if it's like 4? Oops, I refreshed it by accident. Russian peasant multiplication. Can't believe my ancestors were doing this crazy shit. Figuring out odd and even numbers. If the number in the second column is even, write each number at the head of the column. Double the number in the first column and half the number in the second. So here they treat the second number as the, so here's the reverse. And half the number in the second column. Number in the second column is even. Cross out the entire row. Cross out the entire row. Keep doubling and crossing out until the second number column is 1. Oh, so you just keep doing it, but then you just don't add it to the product, I guess. So it's like this. You don't add it? Is that what they mean by crossing it out? Okay. Well, there's only one way to find out, really. Product. AB. All right, let's compile it. 2 few arguments. Oh, sorry, 0. Forgot a semicolon because I've been doing too much JavaScript lately. Can't spell return. What the heck was that? All right. Left-hand operand of comma. What? Left-hand operand of comma expression. I don't know what that means. Let's try 10 times 2. What? Oh. 10 times 2. Okay, well, doesn't quite work. Oh my days. Guys, why am I so bad at code? 10 times 2. 4! What the fuck? How do you get 4? Okay. 9 times 8. How does Russian peasant? 9 times 8. Well, we treat it as 8 times 9. So it's literally 0. So let's see 9 times 8. 9 times 8. 8 times 9. Wow, this does not work. Plot plus M2. Odd. 72 is the only remaining number in the left-hand column, so our answer is 72. Notice that so we get 9 and 8, and it looks at this column. And then it says, okay. Or do we only look at, do we look at the other number? Is that why it's not working? We're looking at the wrong number? Yeah, I think we're looking at the wrong number. 9 times 8. No, but well, let's have 9 times 8. Looks at this number, sees that it's even, and doubles this number, divides this number. Thing is, these are reversed, right? I don't want to look at their code. I want to figure this out on my own. Multiplier. So we keep looking at the multiplier. So everything has to do with multiplier. Multiplier is odd. Till the multiplier reaches 1. That makes sense because we divide this number. We only return product when this thing reaches 1. Let's do a debug. M1, M2. Nine times 8. What happens here? 9, 8. Fuck, come on. New line. C. Nine, 8. 16, 32, 64. Or let's do like 7 times 9. I want to look at this and figure out 7 times 9. Well, 7 times 9 is not 27. It should be 63. 36. Product. How does it even get thing? 7. 7's odd. So product. 7 is odd, so product equals 9. That makes sense. We get 3 and 18. 3 is odd, so we get 27. Yeah, okay, so we're missing something. 1. Oh, I guess we're missing this value here. 7 times 9, 63. Alright. We were missing the last addition. 9 times 7, 63. Alright. Cool. I do wonder how it works though. So it tries to like break it down by groups, kind of. By even groups. True. I mean, let's try the big test case. They gave us this. I guess they gave us an extra test case. I wonder if like it's cool if I kind of implement my own version or not. Let's try their test case though. Okay, let's try this. 2, 3, 4, 5 by 789. 185, 205. 1850, 205. Okay, yeah, it works. Let's just try a huge number. 23958, 233, 5830, 5830. 139676 390. Yeah, okay, cool, it works. And they also want a non-recursive version. Non-recursive, code them in the same three languages and into COBOL. Alright, let's do it in C first, and then we're gonna probably do Fortran next. Long product, or oops, product non-recursive. Pothole case for days. Long M1, long M2. We're passing by value here. You could have another test case, I guess, for the 0. From 1 equals 0, turn 0. Like, what if we do like 0 times 5? Yeah. No, when you do exit. Yeah, it broke. All right. If M1 equals 0, return 0. So this should right away fix it. Nope, that did not fix it at all. I guess we could cheat. Oh, come on. Kill it. We could cheat and just say oh my god, what? What do you want? What's wrong? LD expects long int. What are you talking about? Return product. Implicit declaration of function product. Oh, because I renamed it. So, I mean, if we get Yeah, if you get 0 or 5, like, I guess this number. Would it even work with like negative numbers? Yeah, I guess it does. Maybe not. I think this is fine for now. I don't think it talks about negative numbers here. We could literally just copy his algorithm, I guess, and but would it work with a negative, like -7? Yeah, m is greater than 1. Yeah, it's not even gonna work. Yeah, it only works with positive numbers. It's fine. I just want to see like if we give it a 5 and a 0, it's gonna it'll work. It'll work because the 5 will at some point reach. I think it'll work. Like, let's try this. Like 5 and 0 should give us 0. 0 and 5 should also give us 0. Yeah, okay, yeah, we're good. It works because just m1 is a number that keeps getting divided by 2, and then if you keep dividing 0 by 2, you're going to keep getting 0. But if this number is not 0, yeah. Yeah, that makes sense. All right, cool. So we got that. Let's make a non-recursive version. Non-recursive, which will only really need m1 and m2. We'll need m1 and m2. Shouldn't be too difficult. I guess it's just like while, like you have something like long product starts with 0, and you just have like while m1 is bigger than 1. You just basically say if m1 mod 2 is 1, you add first, or you add and then, yeah, you add m2 and then you just do something like that, and here you just say if well, here if they give you 0, this is just gonna fail, and it's just gonna return prod. Recursive. We got non-recursive. All right, compile time. Let's get a big test case. Let's do this one again. I like this one. 2, 3, 4, 5, 7, 8, 9. Oh, okay, interesting. While m1 is greater than 1. If m1 mod 2 equals 1. Oh, I gotta bring this out. Sorry, I had to bring this out because then you would get stuck with even numbers. So what is this? 2, 3, 4, 5, 789. Whoa, we got a whole different number. Is it this issue again? Well, then we're gonna have to adjust for the zero case. 2, 3, 4, 5. Yeah, it's this case again. True. Edge case. Yeah, because then it's gonna be like 0 plus 5. Just make sure everything works. Russia 80. 08. 8 1. 7 times 9. 9 times 9. Let's test one big number, so we're just sure. 2 3 9 5 8 2 3 3 5 8 30 5 8 30. Yeah, it looks pretty good. All right, cool. So we got input values. They like comments in university. Everyone loves comments. Recursive algorithm. PS. I wrote my own. Non-recursive algorithm using a loop. Using a while loop. You could do like a do while loop. Would that, if I do a do while loop, would that actually eliminate this ace case? No, I wouldn't. I'd actually make the number bigger. Anyways, are we still good? We're still recording? Yes, we are. Okay, cool. All right, so that's C. For now, let's just make like, they love this kind of stuff where it's like, welcome to product calculation in C. Please follow the instructions below. And then I'll do all the other comments later. And of course, I forget a new line. Because, you know, Russia. All right, 5, 6, 30. Okay, cool. So that's C. That's C. Next, we gotta do, let's do ADA or Fortran. Let's flip a coin. Heads ADA, tails Fortran. Heads. What did we say? Heads ADA, tails Fortran. ADA. I guess ADA it is. .adb. I'm pretty sure that's what it's called. Yeah. All right, Russia.adb. I do have an extension for ADA installed that does syntax highlighting. Let me remember what I did here. Yeah, so I did this one a while ago. Procedure. Yeah, oh, this was a word scrambler that I wrote. I'm not sure why these aren't coming up as comments. Anyways, procedure word scram is begin. Procedure. We're gonna have to copy a lot of code here. Procedure Russia is begin end. Where's it end? Is there a semicolons? And Russia. Ada. Hello world. See if I remember anything. I remember Ada was probably the coolest. With text.io, use text.io. With text. Do I have to do this stuff? Yep. Put line. Hello world. Is there semicolons? I think there is semicolons. There's put. There's put. Is there a put line though? There's only one way to find out. Put line, gnat, make Russia, ADB. Missing semicolon, line 6. Hello world from Ada. Guys, this is not an Ada tutorial. This is just me trying to figure out this program in Ada. All right. If we got that. Probably gonna have to write a function. I'm just gonna copy what I did in all this. Function. You're gonna read. You can read positive numbers. I remember that. Function. Okay, let's do this. Function. Product recursive. Product recursive is begin, I think, and product recursive. Oh, return boolean is, and then this is where you define temporary variables, is function product recursive return. I mean, add a numeric types. There's positive, but we still have that 0. Integer, positive, natural, and integer type that starts from 0. Return natural is begin, and then it's gonna take natural word. Oh, sorry. M1 natural, M2 natural, prod natural. Return natural is. How do you return stuff? This is just return? Yeah, return. Let's just return 69 for now. Put. Let's try like 1, 1, 1. I just want to see if it compiles. 39 misplaced return statement. Oh, that goes in here. Should be semicolon. Line 5. Comma should be semicolon. Oh wow, what a good error message. It actually tells you what you're messing up. Whoa. Put no parameter for item. I remember there was something called like a toString or something like that. toString. I remember I need this. This is for like line endings, like new lines and stuff. I remember I need that. Turn element. How do I print an integer? Put line. Product recursive. Return 69. Found type. Okay. So what I do, like toString. Is that a thing? toString. Print integer. Add a. Oh, apparently I looked this up before. Put number. Integer text AL. Integer. Integer text AL. Is that what I gotta do? No, that's not what I gotta do. Put line number. Put number. New line. New line, is that a thing? Integer image. Okay, add a print natural. How to output integers. Image. Natural. Image. I remember this image thing. Oh. Oh, okay. Cool. Good stuff. Good stuff, good stuff, good stuff, good stuff. Put. All right, sweet. We can print stuff. We can do the if statements are pretty simple here. Like if M1 is like 2 equal signs. Or can we use 0? Is 0, then return 0. We can do that, right? We can do is. We gotta put this in brackets, not Python. Okay. It is like Python, kinda. Alright. Cool, so that works. Alright. Let's do like if equals 1, return M2 plus prod. Now, if is number even, is there, you can just do mod. Rem. I knew it was going to be complicated in ATA. We can't just do like the C way. If rem, if n rem2, if m1 rem2. But why do we have to do this? I thought brackets didn't matter. M2 equals 1. Then, and if yeah, this should be fine. Then we return product recursive of M1 divided by 2 ATA integer division. This is how you learn how to code. You just Google, then you just use it. ATA floor. Oh, can you just do this? But I guess it's not really a floating point. We'll just try this for now. Have 2 times 2 prod plus M2. Right, that was our code. And then we just do that. But we don't add the M2 in the end here. Let's add our comment. I don't know why there's no comment highlighting. Alright, how many errors are we going to get? No errors. Well, we can't really run it yet. Let's run it with, what was our example? Let's do like 6 times 7 or something. 6 times 7, is that 42? That looks kind of correct. That looks kind of correct, I guess. 0 times 7. 0. Nice. Let's do like a fuck number. I should really get, like, I should really save these numbers. 5, 8, 30. Five, 8, 30. All right. Let's see. Constant error. Overflow check failed. Constraint error. Ooh. Cool. So it thinks it's an integer. So we need to make it a long data type. COVID-19. What does that have to do with anything? Overflow check failed ADA. ADA large natural. ADA long integer. What are these called? Integer types. Signed integer. Long integer. Okay, this is good. Is there a long natural? Is that a thing? I probably shouldn't make these long naturals. Long natural. I guess we can make these long integers. How do I do this? Long integer. I'm just guessing at this point. I think it's just you do this. 26, 23. Oh. Okay. I think it worked. Does it work without this though? Or do we need that? Yeah, I guess we don't even need that. I guess image is like a 2-string and nada. That looks about right. 139,676 290. Yeah, looks about right. I remember we can redefine stuff. Like here. Type uString is new. We can do this here, I guess. Is then we can actually indent this and no, that actually stays here. Type long integer is new long integer, and then we can actually replace all these. Sorry, that's what changes back to long integer. There you go. I don't know why it's not showing comments. For whatever reason, it's not showing comments. But all right, you gotta also write the non-recursive version. Function product non-recursive M1 li, M2 li, return li is begin, and we're gonna have to define a variable in here. That's gonna be our product. How did I do it? Here, you just do this. Okay, so we gotta do product prod is li. Turn 1. Missing line 27. What, this? Yeah, okay, makes sense. Alright, so here we just pretty much copy this. So we just define this. We write our little if statement here, like if m1 equals 0, then to return 0, and if, and then we go while m1 is greater than 1, loop, and loop. Then we go here, if m1 remainder 2 is 1, then, and if, here we say prod plus equals m2, I think, right? That's what it was, yeah. And we just do the basic stuff, m1 divide equals 2, m2 times equals 2. I don't even know if you can do that, so I will just do like m1 equals m1 divided by 2, m2 equals m2 times 2, and then here just return prod plus m2, This reminds me of what's that one weird language? Turing. Actually reminds me a lot of Turing. $35. Prod plus M2. Assignment in. Mode parameter. Not allowed. Oh, it should be in, out, or something. Is that a thing here? In. I guess we could do it in C. It's basically the error seems like we're not allowed to modify. We're not allowed to modify the input parameters. So let's see if there is a way you can overwrite, or I guess specify. Yeah, it's in constant view. In, out parameter. How do you do that? Add a in, out parameter. Add a in, out parameter. Ah, fuck, come on. In, out parameter. Add a. Come on, give me a code example. I don't want to create two new variables. In, out. In, out. Can we just do out? Oh, so then it, product non-recursive. Oh yeah, I guess here we never actually modify the value, and here we do. Interesting. We can just copy the thing. And we're gonna specify set the input parameters to in, out mode. All right, cool. Let's also do this. And take out this parameter. Compilation error. M1 must be a variable. Must be a variable. Why? Oh, I guess because it gets, it gets modified, so it must be a variable. You know what? Fuck it, guys. We're just gonna keep it. We're just gonna keep it simple. We'll call it AB. we're gonna have to M1 li equals to A, M2 li, not L1, li equals B. Cool. We just mapped the variables to these parameters here. All right, let's go. Put we could just put line, but that's for scrubs. I'm just gonna copy what I have here. Actually, you know what? Maybe it's not for scrubs. Just does make things a little easier. Put line. Enter the multiplier. We're gonna have to read in a number. Read, what do we call it? Large integer. Auto read integer. Let's see this, 2017. Integer value get line. Okay, so I guess we should have to define stuff here. I'm going to do like input A, input B, and then we're going to go input A equals large integer value of get line. That looks about right. And then we're going to do this thing. Let's go put line. This could actually be a put if we're trying to be consistent. And then it goes to a new line. Yeah, it goes to a new line. And we go like input B equals the value of get line again. And then the user hits enter. And then we can print out recursive, non-recursive. Recursive. Non-recursive. All right, who thinks he'll compile? All right, this is it. Oh, shit. We forgot to use input A input B, input A, input B. All right, ADA. Here we go. 6 times 7, 42. For the last time, we are gonna clone this. Fuck. 958.233. 958.233. Not 58233. 5830. 390. 498. 390. All right. We are done with the ADA program. I wonder if there's a warnings. Like, is there a wall? Yeah, there's no warnings. That's our ADA program in the bag. Let's remove all the stuff it generated. ADB. Remove ADB. Ali. That Oh no, that was actually a really bad idea. Let's copy this. Remove Russia. I shouldn't have removed ADB. We copied it. Let's reconnect. That was really stupid. Russia ADB. That was kind of dumb. I wanted to remove the files it generates, not the actual code itself. So let's just make sure it compiles. No NTs. Oh, yeah, let's just take this out. Yeah, let's just do 5, 6, 30. Cool. Let's not be stupid. Let's remove the Ali file and the O file, and just remove Russia. All right, cool. We got Russia in C. We got Russia in ADA. Cool. Now, let me take a quick break, quick washroom break. I'll be right back. How do I pause this? Can I even pause this? One sec, guys. I'll be right back. All right, we are back. We're still recording. Yes, we are. Cool. All right, well, we're an hour and 20 minutes in. We got the ADA and the C code out of the way. Cool. Next is Fortran. F95 is what we use in Fortran. Russia F95. All right, Fortran. Let's see Fortran here. Program, implicit, subroutine. All right, well, I think Fortran is a little bit simpler than ATA. Program Russia. Add program. But I don't think there's semicolons. Yeah, there is no semicolons. Add program. Implicit none. Implicit none, I'm pretty sure has to do with when you create variables, if they start with a certain character, I think it like auto assigns a type to it or something. So we don't want any of that. Dimension, that's array. What we care about is this integer. And we're going to write a subroutine. So we got integer input A, input B. And I guess we create it like this. I guess here, let's just replace A. Oh, no. Well, A. Okay, you know what? Fuck it. Just fix up this thing. So my code is consistent. I'm gonna compile all these in a bit. I guess we could try just compiling this. Like sometimes it's just like weird things happen. And then, you know, I don't know how to react to it. Anyways. Oh yeah, I remember this now. The weird Fortran had this weird printing thing. We define subroutines outside of programs. Yes. Subroutine product, or is it recursive product? Product recursive, and then it takes, cool, we don't have to M1, M2, and prod, and subroutine. Do we have to give it a name? Yes. This should be fairly simple. Here we use brackets in if statements. It's kind of the same. If And we just do a quick return 0. Oh, there's no return statements. Hmm. Mm-hmm. Oh, I remember this. Yeah. This is going to be a bit more interesting. We have to map our variables, and we also have to specify in and out, which is cool. All right, cool. Let's just do this. Implicit none. And then we map the function parameters to variables. Integer, intent, in. Intent, in. And then we just M1. M2. Can we define them on the same line? I guess we can, but whatever. Integer, intent. Now, this could be interesting. I think in and out makes sense because we take it in, but we also output it. So I think for this case scenario, in and out makes the most sense. Because, yeah, we get it as an input. So I guess we're going to have to define it here as well. Set it equal to 0. Yeah. Okay, cool. So then we can... Actually, there's going to be no returning. Okay, this is going to be a bit more interesting, I guess, because... Fortran. How do you exit out of a function in Fortran recursion? Is there a procedure? Huh. I didn't know you can do this. Recursive function. Wow. I didn't know you can do this. Result. Result feeble. Interesting. Result prod. And we just define it here with no intent. Can we even define it here? Okay, I've never done this recursive function thing. F1. All right, let's just try to do this then. equals 0. Then if y equals 0, so there's still no return. That's literally, well, then these kind of have to be in and out, I guess. Because we pass them in, but we also do operations on them. Right? That makes sense. So if M1 is 0, then I guess prod equals 0. Right? Then we just kind of do else if M1 equals 1, then how do you do else if statements? I guess it's going to be something like this, like then prod equals M2 plus prod. And then otherwise, else if, I guess. Then here we do like mod M1 2 equals 1. Because then if it just matches this condition, I'll just do this and I'll, go into recursion. This is weird. So then it goes prod equals, oh, this is going to be a weird way. It's going to be weird to wrap your mind around this. Because then it'll calculate we add M2 I guess it's gonna be like this. It feels to me as if it's something like this. How do you compile Fortran? Compile Fortran. Fortran Hello World. Fortran Hello World. Oh my god. Hello World. Compiling. F95. G Fortran. That's the one. That's the one. That's the one we got. G Fortran. O. Russia. Russia F95. Non-variable expression. Tampem 1, Tampem 2. All right, let's see this. So compiled. Six times 5. Input A, input B. In and out. Six five prod. Or let's just actually run this up here because this doesn't return an integer. It's just a function. And then prod. I think that's how. What is it? Call or something? Call. Oh, okay, let's see. Global name is already being used at function. How do you call this function? Ah, shit. How do you call this? Is it run? Is it run? No. Run function Fortran. call function. Real function average. Call. It returns product. Oh, I guess we have to assign it then. Oops. I guess we have to assign it to product. Oh, this is gonna be a weird. It's gonna be just a weird thing. I don't think it's gonna work. Has no implicit type. Unknown integer 4. What? Return type mismatch. Result. Result F. What do you mean it has no implicit type? Call a recursive function. Well, integer ACK. Right ACK. What? Integer. Product recursive. Right. Like this? Is that how I was supposed to do it? Oh. Oh, what the hell? It worked. It actually worked? What? I don't believe it. There's no way it worked. It worked. Three, two. Oh, what the heck? $30. The real question is, will it work with a big number? And why is the formatting so weird? Let's go back to our thing here. The real question is, does Fortran just support huge numbers by default? This is the real test. If this works, it actually worked. Okay, no, it didn't work. I guess it overflowed because it's negative. Fortran long integer. Huge. 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 Kind. Kind equals huge 0.8. Can we do that? Kind. Kind equals huge 0.8. It's no implicit type. Integer value too large. Kind equals 4. Selected int kind. What's wrong? Type. Oh. Kind. Alright, cool. Passed integer to integer 16. Well, is it gonna fuck up printing it? Whoa! What the fuck? Kind equals 32. Can we even do that? Like, what am I not understanding here? Selected int kind. My login type integer parameter. Print large integer Fortran. Huge. Print huge. Kind. Print. Module for handling big numbers. Damn, these are really big numbers. Well, I'm not gonna import a library for this. Huge. Largest integer. Wow, why is this proving to be difficult? Type mismatch in argument. M1. Pass integer 4 to integer 16. Passed integer 4 to integer 16. Argument mismatch. Long int in Fortran. Why does Fortran make this more difficult than it should be? Kind. Maybe I'm just doing a number that's like too big or something. What was the actual answer here? 139. Yeah, this is too big. It's just doing something weird. It's 5 times 6 work or no? That's the real question. Does 5 times 6 work? No. Okay, so maybe it's just the printing. Maybe it's just the printing that's wrong. Well, there's only one thing we can kind of do is do this. And just kind of do maybe do something like this. $30. Nice. So I guess it just assumes that we're passing a certain type of number. Let's just go all out. So it can perform like a huge multiplication. Oh! That doesn't work. It's too big. $393. Oh, it doesn't actually work. $390. It doesn't actually work for some reason. 239 582. 2345 79. It doesn't actually work. Or does it work? $1850 It does work. So why is it being weird? I don't know. Does that change anything? Ooh. Can't do that. 18205. So it like actually doesn't work for some reason. It's off by 3. No, it works now. 498. Oh, what the It has to be the junk memory. Recursive function default value. I think it's junk memory. We're not setting the prod. We're not setting the value correctly. Alt sub equals none. Prod equals 0. Can we do that? No, we can't. This Python. Did I not? Oh. Fortran. Intel. What does Intel have anything to do with this? Digit A. Prod. M2. Goes over prod. I think this is where the issue happens. Because we never actually use the number itself. Ac. Oh, that's just a comment. It's just weird. This is like weird. Prod equals 0. It's like weird. Like, look at this. It like gives me random values. Like it worked the first time, and it just didn't work. Fortran gives different values. You'll get just garbage. Okay. Somebody in 2010 had a similar problem. Let's see. compiler. You have not used. Should have implicit none. I do have implicit none. Maybe if we compile it, but like std equals f95. Let's try this. Equals f95. I don't know. This is like a weird. It's like a weird code. Okay, 390. No, it still gives me random junk. It works the first time and then it just stops working. I don't understand why. Okay, well, let's have these for intent out. And then we'll just have prod and 2. That's like a thing. Ah, this thing's so annoying. Is not a dummy variable. I don't know what that means. Man, out of all the languages, oh, true. Why can't I set this to 0? Like, why does it gotta be like? Cannot have an initializer. What if we do What if we do a recursive subroutine instead of the function? Let's try that. Recursive subroutine. Product recursive. It's going to take 1, M2, and then prod. And subroutine. Implicit none. Integer, intent in out. We had the same kind of deal here. Integer kind equals selected int kind 12, intent in out. M1, M2. And prod. Actually, they're all in out. And prod. And then, you know, you do all this stuff here. Or let's say prod is out. There's no return. That's the weird thing that I gotta wrap my head around. There's no return. So it's like whatever the last value is. I guess we'll just try to do this. Intent out prod. We're gonna try to follow what the guy in Stack Overflow did. And then we kind of have this like if m1 equals 0, then like if it's 0, then product is 0. That makes sense. And it's kind of like the same structure here, like else if m1 is 1, then, you know, prod is equal to prod plus m2. And I guess we can like even structure it further, like else, like if, you know, mod m1 2 equals 1, like then, and if then we just kind of do this thing where it's like product okay, and out, no, no. Just call like call. this might not work. We're learning. I did Fortran the longest time ago. Oh, did this connect? Internet issues. All right. Yeah, this one, I hate this one the most so far. Non-variable expression. Non-variable expression. Selected integer kind 12. Temp A. F A and B. A is equal to M1 divided by, I'll just have these as in. And then 2 will not be by 2. B equals M2 times 2. Of AB. Of AB. Then C. Then C here is going to be M2 plus prod, M2, ABC. And then prod, we can just make it out. Oh my fuck. Implicit type. C has no implicit type. Oh, well, I guess because we forgot a comma here. But we don't even need a comma here though. Integer. A, B, C, 2. No comma. We got 0. I guess because we never set product here really. But I think we're getting close. Prod equals C. What? What's wrong? What's wrong, baby? Why are you broken? Is it this? $920. That doesn't look right. $146. Product equals M2. No, that's not right. Um, feeble temp. Prod equals C. Prod equals prod temp. Maybe this is the line that we shouldn't be doing. Whoa. C. Temp. Temp. So if we land here, it would be 0. If we land here, it's going to be product plus M2. Product was product plus M2. But that doesn't really do anything, yeah. Wow, this actually got me stumped a bit. C. $5,830. That just gave us product equals product. I don't understand why it's just different values every time. This got me stumped. Might need to take a break, come back.